this question they have said that a variable circle passes through a fixed point P, Q and touches the x-axis. So we have to find out the locus of the other point of the diameter through A. Let me draw the diagram first. This is the circle. It is passing through a fixed point P, Q and it is touching the x-axis. So this is the diameter. B is the other extremity of the diameter and we have to find out the locus of point B. Let us say H, K be any point on the locus. Therefore, the center of the circle will be nothing but P plus H by 2, K plus Q by 2, correct? Now, since the circle is touching the x-axis, therefore its radius will be nothing but K plus Q by 2. Am I correct or not? Is it clear? Okay. Now, radius of the circle is under root P minus H whole square plus Q minus K whole square divided by 2. Okay. Now, these two will be equal. This one and this one, they represents the radius of the same circle. Therefore, K plus Q by 2 equals to under root. Is it okay? So that implies squaring both sides we get. So from here we can write that equals to, therefore the equation of the locus is it clear? Therefore our option A is the correct one. This is again a problem from the easier side. Let us move for the next problem. 3 points are given. Let me plot it on the coordinate system. This is point P, which is the origin. This is Q, which is 1, 0, and this is R, which is half, root 3 by 2, correct? Now, if I join those points, we are going to get the triangle PQR. Now we have to find out the center of the circle for which the lines PQ, QR and RP are the tangents. Now we have to find out the center of this circle. If we observe carefully, we will find that the length of PQ is 1. Length of PR is again 1. And length of RQ is also 1. Therefore, triangle PQR is basically an equilateral triangle. And we know that for an equilateral triangle, incenter and the centroid are the same points. Therefore, the center of the circle is the centroid of the triangle PQR, which is equals to, which is the center of the circle. Here it is coming to, is it clear? Therefore, our option C is correct. Okay. I will rank this problem as a moderate one. Okay. Let us move for the next problem. Here the equation of the hyperbola is, here A is cos alpha and B is sin alpha. Therefore, its eccentricity will be 1 by mod of cos alpha. Is it clear? Now, cos alpha is A, therefore, AE equals to 1. The foci of the hyperbola is plus minus AE, 0. Therefore, the foci is plus minus 1, 0. So, when alpha varies, your foci remains fixed. It is independent of alpha. So even alpha varies, your foci remains fixed. Therefore, your option C is correct in this problem. It is again from the easier side. Let us move for the next problem. Now for an ellipse, S and T are the foci. Let me draw the ellipse. Let us say this point is S and this point is T, and B is the end point of the minor axis. If STB is an equilateral triangle, this triangle is an equilateral triangle, clear? Then we have to find out the eccentricity of the ellipse. Now look it carefully. The foci of the ellipse are AE, 0 and minus AE, 0. Now we know that from the property of ellipse, SB plus BT is equals to 2A. Now SB, BT and ST, they are all equal because it's an equilateral triangle. Therefore we can write 2 times ST equals to twice A. That implies ST equals to A. ST is nothing but 2AE, which is A. Therefore your E gives you half. Therefore your E comes to half. Therefore the eccentricity of the ellipse is half. Hence option C is correct. Is it clear? It is again from the easier side. If you know the alternative definition of an ellipse, you can easily solve this problem. Is it clear? Now let us move for the next problem. Here we have to find out the directrix of the hyperbola given. Let me just convert this equation in the standard form of hyperbola. We get Is it clear to all of you? Now here A is root 13 by 3, which is same as B. Therefore its eccentricity is root 2. Okay. Now the equation of the directrix will be capital X equals to plus minus A by E, where capital X is X minus 3. Therefore, the equation of the directrix of the hyperbola becomes Is it clear? Therefore, the option A is correct for this problem. Is it clear? Now again, this sum is a board level sum. Okay.